Module 6, Lesson 13, Describing Variability Using the Interquartile Range, or the IQR. Don't be intimidated. Lots of big words. We'll be okay. We got this. All right, I can statements. I can describe how data might have been collected. I can find the median of a data set. I can describe the variability using the interquartile range, or IRQ. So looking at our 4 big steps here for statistics, we're actually going to be working on steps 2, 3, and 4. We're going to take at least a minute or two and think about ways we could collect data. We are going to summarize data by finding the median and the IRQ, and we're going to use data summaries to answer some questions. So in Lesson 12, the median was used to describe a typical value for a data set. But the values in a data set vary around the median. So we found the median, the middle point, but then we had all of this stuff outside of the middle point. And the question is, what is a good way to indicate how the data vary, or how spread out is the data? Remember, when we looked at the mean, we looked at the minimum value and the maximum value and talked about the variability. Well, how do we talk about the variability when we're looking at the median? And this is a question that we're going to explore. So first thing we're going to do here, and I'm doing this lesson out of order from the math workbook. If you go to, in our students' workbooks, page 287, we'll go through the example for how to find the interquartile range, and then we'll go back and look at some of the other questions. So the first thing we need to do is we need to put the data in order from smallest to largest. And we lucked out on this. Yay, the data is already in order from least to greatest. So we've got our data set in order from least to greatest. Second thing we want to take a quick look at is what is the minimum and what is the maximum. And in this case, we've got the minimum as 1 and the maximum as 17. Whenever I look at a data set, I always like to have some idea of where is it starting and where is it ending at. Where is the beginning, where is the end? So step 1, put it in order. Step 2, take a quick look and say where is our minimum and what is our maximum. Step 3, we find the median. So we need to find the middle number of our data set. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 numbers. So I've got 17 numbers, which is an odd number, so I'm going to take 1 away. The 1 is going to wind up being the median. And I've got 16 there that I divide by 2, and I've got 8 numbers on each side of the median. So I need to count 8. 1, 2, 3, 4, 5, 6, 7, 8. Here's the median. And 1, 2, 3, 4, 5, 6, 7, 8. There we go. So I have the median. I have my lower half. And I have my upper half. So to find the interquartile range, the IRQ, the first thing I need to do is find the median. So 17 data points, the ninth one from the smallest to the largest is the median. So this is number 9, no matter which direction you count from. So we now need to find what is known as the lower quartile and what is known as the upper quartile. So I have my median as 10. That divided my data into 2 parts. Now the word quartile has this quar in here, and we can think of that as quarters. So I've cut into halves. Now I need to cut into quarters. So I need to look at my lower half, and I need to find the median of my lower half. So I've got the median of the whole data set. Now I need the median of the lower half. And I've got 1, 2, 3, 4, 5, 6, 7, 8. So it's going to split 4 and 4, and I need the middle of 4 and 6. 4 plus 6 is 10, divided by 2. That's going to give me a median down here of 5. Come over here to the upper half, and I've got 1, 2, 3, 4, 5, 6, 7, 8, and I've got 1, 2, 3, 4, and I've got 4. So I need halfway between 15 and 15, which is lovely because it comes out as 15. So I've got 3 numbers now to describe my data set. I have the median, I have what we call the lower quartile, and I have what I call the upper quartile. Now all 3 of these numbers are a median. The 10 is the median of the entire data set. The 5 is the median of this lower half. And the 15 is the median of the upper half. Now what's happened here is I have actually cut my data into 4 equal size pieces. I've got 1 piece, 1 piece, 1 piece, and 1 piece. So I've got 4 equal size pieces. Thus we call them quartiles, quarters. Now to find the interquartile range, once I have found the lower quartile and found the upper quartile, inter, I-N-T-E-R, means between. So we are looking at the range between the quartiles, and that's this quartile and this quartile. What is the range between these quartiles? So we'll take 15 and we'll subtract 5, and we'll find that the IRQ is equal to 10. So we're asking how far is it from the first quartile, the lower quartile, to the upper quartile. You will sometimes hear the lower quartile referred to as the first quartile and the upper quartile referred to as the third quartile. All right, I know my board is a big mess here. It'll be okay. So the lower quartile is halfway between the 4th and 5th data points, so halfway between here and here. And then we've got halfway between here and here, so I've got 5, 10, and 15. And my data is cut into quarters. And I'll take 15 and minus or subtract 5 and find that the interquartile range is 10. Now at this point some student may think, oh, the interquartile range is always the median. No, it is not. Please do not make that mistake. In this example, it just worked out that the median looks like the interquartile range. It doesn't always work that way. Please don't make that silly mistake. All right, so we've walked through the steps, how to find the interquartile range. Now we're going to look at some of the exercises. So in your math workbook, you'll flip back a couple of pages. In lesson 12, you thought about the claim made by a chain restaurant that the typical number of French fries in a large bag was 82. Then you looked at data on the number of fries in a bag from 3 of the restaurants. So the restaurant claims 82, and then we went to restaurant A, B, and C, and we collected data. How do you think they actually got this data? What did they do to collect it? This would be a time to pause and think about that for a second. How did they come up with the numbers of French fries in the bags? Well, they probably went to the restaurants and they probably ordered a bunch of large bags of French fries. They probably went through the drive-thru and said, I need 20 bags of large fries. Now, some of the problems that they ran into. Well, how many of you have ever got French fries and some of the fries were broken? So how are we going to count those? And have you ever got some of those French fries that are a little bit shorter and some of them that are really long? Are you going to count all of those as being the same? So some of the problems that you might run into with data collection, you need to think about that before you start collecting data. what are some of the problems that I will encounter and what is my plan to overcome those problems? All right, so what are some situations, some scenarios would give counts that might not be representative of typical bags? What might happen to get some of those numbers that are really low or some of those numbers that are really high? Well, there might be different workers, so we might have different people who are filling the bags. So if I bought the bags at lunchtime, they might have different numbers than if I bought the bags in the evening time. It might be that some of the restaurants weigh the bags, so they don't count the French fries, but what they do is they say we're going to put a half a pound of French fries in each bag. And that could lead us to having different numbers of fries. The weight of the bags might be the same, but the number of fries might be different. Once again, things to think about as you are collecting data. So here we go, exercise 2. The medians of the top half and the medians of the bottom half of the data for each of the 3 restaurants are as follows. Now, they were really nice for us. When they put this problem together, they didn't tell us that we actually had to go out and find all of the medians and the lower quartiles and the upper quartiles. But I am going to quickly show you how, for restaurant A, we would find all of this information. So we've got restaurant A here, and the first thing we need to do is find the median. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We've got 20 data points, which means the median needs to be in between 10 and 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is going to be between 80 and 84. It's going to be 82. 80 plus 84 is 164. Divided by 2 is 82. All right. So that's the median. But to find the interquartile range, I need the median of the lower half, and I need the median of the upper half. So I know that I have 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to split this in half, 5 and 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I have 77. 77 plus 77 divided by 2 is 77. So there's my lower quartile. Now I need to come over to the upper half and find the upper quartile. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I need halfway between 87 and 88, which is going to be 87 and a half. So now I have a lower quartile. Now I have an upper quartile. And to find the interquartile range, I find the difference. So 87 and a half subtract 77 is going to leave me with an interquartile range of 10 and a half. So that describes what is the distance, or how far apart are these two numbers. And we'll talk in a few minutes about what exactly that means. So the first thing to do is find the interquartile ranges. So this would be a great time to just pause, take a moment, get out your calculator, and subtract the numbers here and find the interquartile ranges. So here we are looking, we found our interquartile ranges. We've got 87.5 minus 77, which gave us 10.5, and 83 minus 76, which is 7, and 84 minus 78, which gives us 6. So we have the interquartile ranges now. Now the question is, which of these had the smallest interquartile range? Stop and think about that for a second. And the answer is it's restaurant C. The smallest interquartile range is here. It's 6. Okay. So what does that tell us? What that tells us is that the data is less spread out around the median. It indicates the spread around the median number of fries is smaller than for either of the other two restaurants. About half of the data are within a range of 6 fries near the median. So the median is a pretty good description of what is typical. A lower interquartile range is going to tell us that the data has less variability. Now I'm going to go back one slide here and take a look at what that looks like on our number lines. So we had 87.5 here, and we had 77 here, and we can see that this covers 10 fries. So we've got a variability here of 10 fries. If we look at restaurant B, we're at 83. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Ooh, I think I'm missing one. Oh, maybe not. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5. So we've got 83, and we've got a 76. 1, 2, 3, 4, 5. There we go. So here we've got a range of 83 minus 76, which is a range of 7. We're spread out by 7 fries. For restaurant C, we've got 84, and it's one of these 84s here, and we've got 78, and it's going to be one of these 78s. Here, we are spread out by only 6. Now, you might notice that the lines are longer here, and that they are a little bit shorter here. Take a look at this. I've got half my answers in this little space here, and there are a whole bunch of them there. Now I've got half my answers in this one too, and I've got half my answers here. So they've all got half of their answers in the middle section. But what we're looking at and saying is, if this is all half in here, how much space does that half take up on a number line? And it takes up less space. So I've got half my numbers, but they're in less space. So they're closer together. I've got half my numbers, but they're spread out over more space. They have more room in between each other. I hope in some way that makes a little bit of sense in your heads. But we'll look at some more representations in a few minutes. All right, so the median of the bottom half of the data is called the lower quartile, and the median of the top half is called the upper quartile. And what fraction of the data would be between the lower and upper quartiles? And explain your thinking. And I just did this. I just talked about it on the last one, but we'll look at it a little bit more explicitly. So we had our 77 here, and we had our 87.5 over here. And the question is, how much of our data is in this section right here? And you'll remember I just said half of the data is there. Within the interquartile range, we will have half of the data, or 50% of the data. The other half is on the ends. We've got 1/4 over here and 1/4 over here, and these represent 25% and 25%. So what we're doing is we're splitting the data into 4 sections, and we're asking ourselves, how spread out is the middle section? So why do we think that this is called the upper quartile over here, and that this is called the lower quartile over here? And of course we had our median down the middle here. Oh, I'm one spot off. Here we go. Our median at 82. And I already talked about this. If you take a look, our data is split into 4 pieces. So we call them quartiles because they are making fourths of the data. So our 3 cuts make 4 pieces of data. Our first cut is called the lower quartile. Our third cut is called the upper quartile. And of course we have the median, the middle here. Or if you wanted to, you could call it the second quartile. So think of quartiles as the cuts we make in the data set to make 4 equal-sized pieces. The lower quartile, well, it is below the median. The upper quartile, it is above the median. Quartile is related to quarter. Lower quartile, median, and upper quartile divide the data into 4 sections with about 1/4 or a quarter of the data values in each section. The lower quartile is the quartile that comes before the median. It's below the median. The upper quartile is the quartile above the median. It comes after. All right, so here we've got our restaurants again, and we are going to mark the quartiles for each restaurant on the graph below. So go ahead and pause, and well, I guess before you pause, you're going to mark where 87.5 is on restaurant A and where 77 is on restaurant A, and then do the same for B and C. So now pause and do it. So here are the quartiles. Double check your work, make sure that your little quartile marks match my quartile marks. And once again, take a look at what you see happening with the data. We looked at this in the form of a list of numbers. Take a look at what it looks like on a number line now. Which of these has the quartiles, these blue lines, the closest together? Which one has them the most spread out, and what does that mean? So does the interquartile range help you decide which of the 3 restaurants seems most likely to really have 82 fries in a typical large bag? Explain your thinking. Well, here we go. The interquartile range does help us look at our data. Because restaurant C has the smallest range, it is spread out over the smallest amount of area. That means that it has less variability. Compare that with restaurant B, and wow, restaurant A is way spread out. Restaurants C and B, their interquartile ranges are pretty close to each other. Restaurant A is very much more spread out. So looking at the interquartile range helps us see the variability of the middle half. How spread out is the middle of the data? That's what the interquartile range tells us. How spread out is the middle of the data? The less spread out the middle of the data is, the less variability. The more descriptive our measure of center is. So what's the interquartile range and how do you find it? The interquartile range is the length of the interval that includes the middle half of the data. So we're looking, our data is cut into 4 pieces, and the interquartile range measures how far it is from here to here. That's the interquartile range. So to find the interquartile range, we find this upper quartile here, and we subtract this lower quartile, finding the difference. So what information does the interquartile range provide? Well, a large interquartile range means that there is a large spread. The middle 50% of the data is very spread out. A small interquartile range means the center part of the data is not as spread out. It covers a smaller range of numbers. So in summary, to find the interquartile range, put the data in order from smallest to largest. Find the median. Find the lower quartile and the upper quartile. The lower quartile is the median of the lower half. The upper quartile is the median of the upper half. Calculate the interquartile range by finding the difference between the upper quartile and the lower quartile. So we subtract the median of the lower half from the median of the upper half. And then we can take a look and we can compare data sets, and we can ask, how spread out is this data set compared to another data set? All right, taking a look at the I can statements. So hopefully you can start and asking yourself the question, so how did they come up with this data? Hopefully you can find the median of a data set. This is the second lesson where we've looked at that. And hopefully you can describe the variability using the interquartile range. You can use the interquartile range to say, all right, this is how spread out my data is. So that concludes Module 6, Lesson 13. This is a little bit different than what you might find in your materials. I tried to pick the things that I thought were most important for our students. If you've got questions, make sure you have a conversation with your teacher and make sure you complete your problem set.